Okay, we're now going to talk about estimation and confidence intervals. This is going to be our first topic in inferential statistics, so we're kind of moving on now, and we're going to talk about how to use information obtained in a sample to draw conclusions about the entire population, and that's known as inferential statistics. And we're going to start with estimation. So when you think of estimation, you probably think of in grade school when you added numbers together by rounding them first, and it just made it easier to add, and you didn't get the exact answer, but it was usually close enough that you could make a decision or draw some conclusion about the total without getting the exact answer. So that's kind of like what we're doing here, but what we're going to be doing here is we're going to use the information obtained in a sample to estimate something about the entire population. So, in particular, in statistics here, estimation is when you use a sample statistic, and that's a technical term. A sample statistic is a number that describes your sample. And so estimation is using a sample statistic to estimate a population parameter. And that's another technical term. So a population parameter is a number that describes your population. Okay? So kind of like the mean of the entire population, that would be a population parameter. And then when you take a sample out of the population and you calculate the mean for the sample, that would be the corresponding sample statistic. So we're going to be using a sample statistic to estimate the population parameter. And the particular example we're going to be looking at is using X bar, which is the sample mean. So using X bar to estimate mu. Okay. So we're going to use a sample mean to estimate the mean of the population. So in order to do this, there's going to be two types of estimates. Okay, the first type is a point estimate. And a point estimate is where you use a single value as the estimate. Use a single value as the estimate. Okay, that would be a point estimate. Okay, so now when you're estimating the mean of the population, the point estimate for mu is the sample mean. That's the best estimate that you can use. So if you draw out your sample and you want to estimate the mean of the population, well, your best guess is going to be the sample mean. The sample mean is a good representation of the population mean. And so when you do a problem, we're going to see this a little bit later, when you do a problem and they ask for the point estimate, they're just asking for the sample mean. That's usually a number that's given in the information in the problem. So there's no formula, nothing to calculate. The point estimate is just the sample mean. Okay? So the other type of estimate is an interval estimate. So there's point estimates and then there's interval estimates. And this is where you use a range of values as your estimate. Okay? So like if I were to let's say my population was the age of college professors. A point estimate might be, I take out a sample, calculate the average, and let's say the average was 47. So the point estimate would be 47, the sample mean. Okay? But an interval estimate would be kind of giving yourself a little margin for error. So you might say, oh, somewhere between 45 and 49. So it's a range of values for your estimate. Okay? And that is that's the idea with the interval estimate. So now I have an example here to help us understand kind of the relationship between these two. And it's kind of a fun example here. This is a picture of me right here. I'm right here in the middle. It's kind of a funny picture of me. Let's see if I can get it into a place where there's not a lot of glare here. There's that light there that kind of causes the glare. That's pretty good. Okay, so this is a picture of me, and this is my dad over here, and this over here is actually Rich Mullins, and I don't know if anybody knows who Rich Mullins is, but he is a Christian singer that my family really, really likes. So he's famous for the song, Our God is an Awesome God, He Reigns. If you've ever sang that song, this is the man that wrote that song. And he's written a lot of other really good songs. That's probably his most famous one. But his other songs are even better. And my sister's the one that fell in love with him first, and then she kind of got me into Rich Mullins, and then both of us got our parents into Rich Mullins. So we all like Rich Mullins. So he's a very interesting individual. But this was at a concert, okay? And this is me here. Notice I'm wearing a jean jacket, but let me just warn you, I was always kind of behind the fad, okay? So, like, I remember when I got the jean jacket, I went to Walmart and saw that jean jackets were on sale for like half price, and I got excited because they were cool, and of course they were half price at that point because they had gone out of style, and that's when I started wearing it, right? And so, so don't use the time of the popularity of like the jean jacket or whatever, okay? I just want to see if you can guess how old I am in this picture, okay? And so at this point, if I was in an actual classroom, I'll have my students actually guess. And oftentimes I get guesses, different guesses here. So I get, maybe 15, 17. I've had people guess 14 or even 13. Some people guess 19. Okay? So people will give me different guesses here of my age, but after a while, I stop them and I say, guess what? Up to this point, everything you've given me here, all of these guesses are point estimates. So when I asked you to guess how old I was, the natural thing for you to do was to give me a point estimate. Just guess what my age was. Okay? So now what I want you to do is give me some interval estimates. And so now I let people give me different interval estimates, and I get different things like maybe 13 to 16, or maybe 15 to 19, or 17 to 20. And these are examples of interval estimates, okay? And after a while, there might be a student in the class, or possibly even myself, who will throw out this for an estimate. What do you think about this? I'm somewhere between the age of 5 and 89 years old. Okay? So, which is kind of silly here, because this is such a bad estimate, isn't it? Of course I'm somewhere between 5 and 89 years old, but that doesn't tell you very much information, right? So there's actually, in one sense, that this is actually the best estimate of all of them here, because this estimate I'm actually the most confident in. And that's a good thing. I have almost 100% confidence. I probably do have 100% confidence that I'm somewhere between 5 and 89 years old. Okay? But it's not a very good estimate. And the problem is, it's not confidence here. The problem is that this estimate is not very precise. And that's another good thing that we want in an estimate, right? we want to have a high level of confidence, but we also want it to be precise. The smaller the interval, the more precise the estimate, the better the estimate, okay? So there's two desirable things that we want in an estimate, okay? We want confidence. We want to have a high level of confidence that our estimate is going to be correct, okay? But we also want it to be very precise so that we got a good idea of what the actual value is. And if you notice, there's actually kind of a trade-off between these two, because I can always get more and more confidence by widening my interval, by making my interval bigger and bigger. But the bigger you make the interval, the less precise it is, right? And I can always gain more and more precision by shrinking that interval down. But as I shrink it down, then I become less and less confident that the true value is in the interval. Okay, so we get this. There is always a trade-off between two desirable things. And those things are precision and confidence. And those are two different things. And in fact, the more you have of one, the less you have of the other, right? Okay? So there's that relationship. So the interval estimates are important because you can get an estimate, hopefully, that you're confident in, but also hopefully one that is fairly precise. So in case you're wondering here, in this picture, and usually nobody guesses it, I'm actually 21 and a half years old in this picture. So I'm a lot older than I look here. And this was taken in Omaha. So Rich Mullins came and did a concert in Omaha, and my family went to see him, and it was really, really cool. One of the really sad things, though, is that Rich Mullins actually died in a car accident, and it was several years after this. But he was very young. He was 41 years old when he died. And I remember when I turned 41, I'm actually 45 right now, but when I turned 41, it was kind of the beginning of my midlife crisis, and it kind of began when I realized I'm now older than Rich Mullins was when he died. And that was kind of the start of my midlife crisis. But just before we go on here, very interesting. He actually wrote songs for Amy Grant. A lot of people have heard of Amy Grant. He wrote songs for her and for some other singers, and he actually opened for Amy Grant for one of her tours. But he was really uncomfortable with the whole music scene, and so he never really got into that. And he lived a very interesting life. He lived on an Indian reservation and taught music to Navajo children. And he gave a lot of his money away. Nobody knew this until after he died, but he lived a very simple life. And he still did concerts, but he didn't tour around on a tour bus. He would actually just hop in his vehicle, go, and he would use, a guitar, just simple instruments. And it was actually on the way to one of his concerts that he got in a car accident and died. So it's very, very sad. So there's a kind of a neat song. It's on YouTube. It's labeled Rich Mullins' Last Song, and he's sitting on the couch in someone's living room playing his guitar, and it's one of his songs that's on a CD. So it's not the last one that he ever wrote, but I guess the people that put this up said this was just days before he died. He was at their house and stuff. So I'll put it up after this in case anyone is interested. But there's a lot of videos of Rich Mullins on YouTube. If you're interested, you can just type in Rich Mullins. So that's kind of a fun picture. So to finish this video up then, I really wanted to emphasize this idea of point estimates and interval estimates and this trade-off between precision and confidence. So let me define the confidence interval before we end. And then in the next video, I'll actually show you how to calculate a confidence interval. So we'll use CI to denote a confidence interval. So what is a confidence interval? So a confidence interval is basically the most precise interval estimate for a desired level of confidence given the information obtained by a particular sample. Okay, so the idea here is we're going to be able to choose our confidence level, and it'll be one of those confidence levels that we looked at in the last video. So either like 80%, 90%, 95, 98, 99. And of course, the higher the percentage, the more confident you'll be in your estimate. And the confidence interval then is you're going to choose your level of confidence, and then you draw out a sample, and the information that you use is actually the mean and standard deviation of the sample, and the confidence interval is going to be the most precise interval that you can get at that desired level of confidence for the information that you gain from a particular sample. And so in the next video, we're going to learn then how to find that confidence interval.